Hello guys, today I'll show you how to make client-side prediction in Unity in C#. But first of all, let's just see what's client-side prediction and server reconciliation. So it's a common technique used in modern game to hide the latency between the player and the server on an authoritative game server architecture. In a simple authoritative game server, the client sends the inputs to the server perceives them, and sends back the player position to the player. Client-side prediction is here to make the player move while he's waiting for the server response, which hide the latency. But this can result in a missed prediction, and it's here that server reconciliation enter. It simply check if the player position in the past match with the current snapshot of the player. Now we got everything, let's get with the tutorial. Right before we start, just saying that I took the code from that website and modified it a little bit, but it should be the same. What I've done, I made a little scene where there is two cubes, one for the client and one for the server. So on each there is a little script called player movement, and it just a little script with the movement. So it's really simple in that case. So it take the input and applied a force with when we call move player. So inputs is a little class that I've made with some boolean called up, down, left, right, jump. There's also a new class called input message, which have a unit called tick and an input called inputs, and something called client state with a unit called tick, a vector tree position, a vector tree velocity. The rotation isn't obligatory. And there's also something called an input called set input, which you just set your input to the actual input that you want. So input.getKey WSAD space, and then it returns it. So on the prediction code, we have a public player movement, or your whatever controller you're using, a uint called tick number, a client state array with called client state buffer with a new client state with a size limit of 1024, which will be your size buffer. The same for the input buffer, and an input called current input. After that, we have on the awake method, we're gonna set up the input buffer. In the fix update or whatever method you use that is called every tick, we're gonna say that the current input is equal to set input, and we're gonna make a new input message called with the tick number and the current input. Once that's done, we're gonna send that to the server. Then we're gonna store in the buffer the our actual position. So here we're gonna move after the player, which is really important that you move the player at this point, because you want to move the player before storing the position of the buffer. That is important. Then we do physics.simulate time.fix delta time, and we do ++ tick number, which add 1 on the server. So it's called player manager. When you receive an input, so what I've done is here I made a little script that called client set input to server. I just find the object and send the input message. So you really need to send the input message, and when we receive it, we just say that we're just gonna move the player with the input message that we got. We're gonna physics.simulate. We're gonna make a new state message. So state message in a new class, which stored the position, the rotation, the velocity, the angular velocity, and a unit called tick. So once we have stored that, we're just gonna say that the message.position will be to our rigid body.position, rotation, velocity, and angular velocity. And something important, the message.tick will be equal to input message, so what we received, .tick ++. Then we're gonna send that back to the player, so to the client. So server send.player position, and when the client receive it, it's gonna apply what he actually received. So the player dot rigid body dot position would be what we receive. So now there won't be any prediction. So if we don't move the player here, we actually just remove the prediction. So what we should get is a simple authoritative game server system with no prediction. So as you can see here, we can see the box that just trying to focus onto the server. So just move the player after storing the buffer. So again, client side is real simple, just calculating the movement while we're sending the input. So now you can see we don't see anymore the red box, so there is no this little tiny latency, but sometime it can do some misprediction. So what we want here, we won't set the input, the thing here on the internet, or even if you're using a little network architecture, even if you're locally, you will get a lot of misprediction. So we're gonna use the server reconciliation. So what we'll do, we'll first calculate the position error that we receive from the server. So we're gonna make a buffer slot called message tick with the buffer slice limit. A position error vector tree, which will be the position that we receive minus the actual past position for buffer. And if the SRQ magnitude is higher than this little tiny number, we'll rewind and replay. So what that mean is that we'll set our, like we did before, we're gonna snap back the player to its position, to the rotation, the velocity, and the angular velocity. And then for each rewind tick, so it's just the message dot tick. So for each tick that we wanna rewind, we're just gonna set the current input like we did here. So we just snap back the current buffer to the good position, and then we move the player. So here we move the player, and then we physics.simulate and set rewind tick plus. Like that, we rewind all the wrong buffer position that we got. And with that, we should be able to have client-side prediction and reconciliation. So as you will see, it won't be real different from before, because as I said, there is no any latency. But on the client example, if we change slightly the mask, you can see here that, well, when it go too far from the red box, it snaps back to where the red box is, but it still smooth. So at this point you can end the tutorial now, but we'll make a little latency system, so you'll see a little latency. But it always ends in the same position. So that's concluded. Hope you liked. If you liked, please share it to your to people. Like, subscribe. Yeah, that's pretty much it. It was Jacob. Bye.